Good day, everyone. We are the researchers from Centro Escolar University, Malolos, Department of Dentistry from the Philippines. We are here to present our research entitled Qualitative Evaluation of Flaxseed Extract via Phytochemical Analysis. Authors are Geraldine Ann R. Avendaño, Lovely Ann B. Cunanan, John Paul O. Mariano, Neil Allen B. Migano, Nolex A. Nofuente II, and Carmela P. Salenga, and our research advisor, Dr. Shirley S. Wong.
Dental caries or tooth decay has been a major healthcare problem for many years, as it is the most prevalent disease worldwide. It dates back to as far as 5000 BC. Dental caries is reported to be one of the oldest and most common disease found in humans. It is a prevalent chronic infectious disease that affects almost 100% of adults. Over 2 billion people suffer from caries of permanent teeth, and 514 million children suffer from caries of primary. The large source and availability commercially of flax seeds has attained the spotlight in medicine for its medicinal uses, especially in dentistry in terms of its antibacterial property. In recent years, studies have proved flax seeds as a health potentiating medicinal and functional food due to the presence of a remarkable amount of bioactive components. The experiences on both dental caries, the abundance and availability of flax seeds, and its promising use in dentistry were considered to conceptualize their potentials as an antibacterial agent via oral rinse. Flax seeds have an antimicrobial effect on certain microorganisms, which is attributable both to lignans and phenolic acid, as well as to long-chain unsaturated fatty acids, especially α-linolenic and linoleic acids.
The flaxseed will be purchased from a local store in Malolos, Bulacan. The researchers will purchase around 1 kilogram of the sample. The seeds will be washed and dried, then it will be grinded into powder form. The powdered sample will be soaked in 90% ethanol for 15 days with intermittent shaking. The mixture will be filtered using Wattman filter paper. The well-concentrated mixtures will be obtained by drying them at 50 degrees Celsius on a rotary evaporator. Then, it will be processed using the water bath method at 60 degrees Celsius. The extracts will be stored at 0 to 4 degrees Celsius in an airtight container until needed. Concentrated extracts were diluted in 10 ml distilled water at different measurements in milliliters.
The researchers will conduct the phytochemical analysis at Centro Escolar University, Malolos to determine the components of the flaxseed extract. Test for tannins and phenolic compounds. For ferric chloride test, a 5 milliliter of flaxseed extract solution will be measured and added to a test tube. 1 milliliter of 5% ferric chloride will be added to the test tube, allowing them to react. A color change of greenish black will indicate the presence of tannins. Test for saponins. Frothing test. A 1 milliliter solution of flaxseed extract will be measured and added to a test tube. The solution will be diluted in 20 ml distilled water and shaken for 15 minutes. A development of 1 centimeter foam layer will indicate the presence of saponins in the extract. Test for flavonoids. Alkaline reagent test. A 5 ml of flaxseed extract will be measured and added to a test tube. The aqueous solution will be treated with 10% ammonium hydroxide solution. The presence of yellowish fluorescence indicates positive results to flavonoids.
A 2 milliliter flaxseed extract will be taken in test tube added with 0.2 milliliter of diluted hydrochloric acid and 0.1 milliliters of Mayer's reagent. A formation yellowish precipitate indicates the presence of alkali. 5 mg of flaxseed extract was measured and treated with 0.5 milliliters of ferric chloride solution and 1 milliliter of glacial acetic acid. Then, 2 milliliters of concentrated sulfuric acid was added, allowing it to flow along the sides of the test tube. Formation of bluish-green upper layer and reddish-brown color indicates the presence of cardiac glycosides. Terpenoids will be analyzed by measuring 1 milliliter of flaxseed extract treated with 2 milliliters of chloroform. Then, a few drops of concentrated sulfuric acid will be added carefully. A presence of a reddish-brown layer indicates positive results for terpenoids.
The preliminary phytochemical screening of flaxseed extracts revealed several polar and nonpolar chemical constituents. The phytochemical analysis of flaxseed extracts showed the presence of flavonoids, phenolic compounds, glycosides, alkaloids, terpenoids, and proteins by simple phytochemical screening methods. The various extracts of flaxseed showed presence of flavonoids, tannins, phenolic compounds, and alkaloids. However, saponins and cardiac glycosides were absent. Flaxseed extracts that were obtained using ethanol presented the highest amount of phenolic compounds and flavonoids. The flaxseed extract obtained via 90% ethanol showed positive results on all phytochemical constituents except cardiac glycosides. Here is a table presenting the results of phytochemical analysis of flaxseed extracts.
This study focuses on the phytochemical analysis of the flaxseed extract, and it was found with the use of different phytochemical methods. Bioactive components including phenols, tannins, saponins, flavonoids, alkaloids, and terpenoids were found in the extract. However, cardiac glycosides were not found in the extract through Keller-Kilianis test. Two of the said bioactive components, which are the phenolic compounds and flavonoids, are frequently cited by different studies for having a role in the degradation of bacterial DNA of selective pathogens. The use of flaxseed has been studied meticulously by different researchers to use it as an antimicrobial substance. It has been proven by several studies that it contains bioactive substances, most importantly lignan, fatty acids, phenolic acid, and flavonoids, which have different bactericidal effects on pathogens such as Phyromonas gingivalis, Staphylococcus aureus, Escherichia coli, and Streptococcus pyogenes, and some of these are commonly found in the oral cavity.